Okay, so good morning, everybody. Yeah, hopefully everybody got the notes. Okay, if you doesn't have the notes, you can get a paper to write down some important notes. Okay, so this is how we will go through this 2 hours lesson today. Okay, mainly, okay, first, before we go through the questions, I will tell you some very important notes. Okay, some very important notes. What I want you to do is if you have a blank paper, is the best, okay, or a full-scale paper, a test pad paper. Okay, this is what I want you to do. First, I will go through the notes, okay, and then I want you to write down the important notes. Okay, why? Because writing down the important notes will make you remember better rather than just highlighting whatever I did with the notes. Okay, students very often they just follow like whatever I do on the notes. I highlight this one, then they highlight. They never really understand what's that. Okay, so you can get an empty paper or whatever paper, or you can just write in the front page if there's empty page. Okay, so here. So let me repeat again. Today we'll be going through the Form 4 Chapter 2 atomic structure. We're not gonna go through the solid, liquid, gas thing. Okay, the melting and freezing, the cooling and heating curve of naphthalene. That one we're not gonna go through. There is a simple experiment you can study yourself. Chapter 3, we do calculation and the very popular exam question, empirical formula. Okay, so first, let's start with the chapter 2, guys. For Form 4 chapter 2, the atomic structure, here are some very important notes. Okay, please don't copy first. Don't copy first. You just listen. Later, I'll give you time. It's either screenshot or I let you copy. Don't worry. So you have to listen and try to understand. If there's any question, you ask me. Okay, ask me on the spot. Don't wait until the class end only to tell me, teacher, I don't understand everything you say. All right, okay. So start with the chapter 2, atomic structure. So since we talk about atomic structure, you have to know that an atom looks like this. Okay, atom looks like this. In the atom, we always have something called the nucleus. All right, so this is nucleus. In the nucleus, we can always find proton and neutron. And then in the shell, we can always find electron. And then this proton, neutron, and electron, they are all known as subatomic particle. Okay. Don't copy first. You have to try to understand what I say. So subatomic particles are the 10 proton, electron, and neutron. Is that okay? And okay. Then the next thing I want to go through is in the nucleus, because we are having proton and neutron, and the total number, okay, because we can count, right? We can count there's how many proton, there's how many neutron, there's how many electron. So the total number of proton and neutron, they are known as nucleon number. Is that okay? Okay. So if you can understand this already, don't have any question, you can write down somewhere already. Okay, I give you 1 minute. You write down somewhere. Write down somewhere. So atom is made of 3 subatomic particles, the pen, proton, electron, and neutron. Okay, once you're done, you let me know. Once you're done writing the notes, let me know. Done. Okay, good. The rest of you, done? Okay, done. Okay, right. Let's continue. Anyone not done yet with this? Okay. The next thing is, okay, after you know that an atom is made of proton, electron, and neutron, now there's actually a format for us to present the information. Okay, how many proton, how many electron, and how many neutron? Because we're not going to draw it out every time. Some atom there has a lot of electron, and lots of proton. So there's no way we can draw the whole thing out. So there's a simple format that helps you to present the information of an atom. We call it as, we call it as standard representation. Okay. A standard representation is actually a format that shows the information of an atom. So what does it mean? So for example, if I have a sodium atom, I will write its formula as Na, and then on the top left corner, we will write 23, which is the nucleon number of the atom. And then at the bottom, we will write 11 as proton number. So this is how we present the information of an atom. Based on this standard representation, we actually able to tell there are how many proton, there are how many neutron, and there are how many electron in the atom. Okay. So there are how many proton in this sodium atom? You just look at the bottom one, the bottom number 11, right? Then the answer will be 11. There are 11 proton. And then to get the neutron, how do we get the neutron? Since just now I said that nucleon number, nucleon is actually proton plus neutron. Nucleon, okay, we call it as nucleon because this place is nucleus. So everything in the nucleus, we call it as nucleon number. All right. So that's why here, the 23 is actually proton plus neutron. If I only want the neutron, I should minus the proton off. So I will be using 23 to minus 11 to get 12. That's how you get neutron. All right. Okay. And then for electron, they did mention nucleon, which is proton and neutron. They did mention proton, but they never mentioned electron. So there are how many electrons in this sodium atom? It will be the same as, yeah, very good. It will be the same as the proton. Electron and proton in an atom will always be the same. Okay, will always be the same. So proton and electron, they're the same in an atom. Is that okay? So you have to remember that this format is called standard representation. So is there any question? If no question, then you can write it down. So these are some very important notes that you should go through every time for your revision before exam. So when you look at it, you will know, okay, so these are the most important things that you must know. Because if I show you the notes, right, it will be like, oh, there are quite a lot of things to study, like, oh, there are a lot of things to read. maybe you lose interest and you don't really know what are the important parts. Okay. So when I go through like this, you will know, oh, this part I know, which parts I don't know. Okay, you can write it down. Okay, done? Done, ah? Okay. Anyone not done yet? Anyone not done yet? Done, ah? Okay, good. Okay, final part. Okay, final part. Please listen carefully. Here, atom. Right down here. Okay, wait. I don't want to write this because I think this one is simple. I write the more important one. Okay. Electron arrangement. I believe everybody knows what is electron arrangement, right? Can you try to tell me what's the electron arrangement of this atom? What's the electron arrangement of this atom? Sodium. What's the electron arrangement of sodium atom? Do I have to go through this? Electron arrangement. What's the electron arrangement? Oh, okay, good. Yeah, okay. So everybody can tell that it's 2, 8, 1. So if you doesn't know how to get electron arrangement, please let me know. Okay, you all know, right? Okay, good. Okay, then now, there's something I want to mention now. Okay, very important one. Okay, listen. If cannot, then GG, yes, true, correct. Almost June already, and you still don't know what's electron arrangement is really GG. Okay, here is the very important thing. We did learn it in the class last time, but some of you joined like maybe during the middle of chapter 3, so you might miss this part already. Okay, and it is very important. Okay, this one okay, okay, and this part is atom versus the ion. Okay, you have to, okay, as a chemistry student, we must know the difference between an atom and ion. Okay, if you can't tell the difference between an atom and ion, you are not a chemistry student. Okay, so what's an atom and what's an ion? Atom is a neutral particle. That means it doesn't come with any charge, no charge. But then, an ion, it comes with charges. It can be a positive charge ion, it can be a negative charge ion. It comes with charges. Okay, it can be positive, it can be negative charge. So here I'm going to explain why an atom is always neutral. Atom is always neutral because they are having the same amount of proton and electron. Proton is the same as electron. So that means, like the case just now, the sodium, it is having 11 proton. It is having 11 electron. 11 proton give it a charge of positive 11, while 11 electron give it a charge of negative 11. Positive 11, negative 11 will be equals to 0. So that's why it doesn't have any charge. Wait, why am I lagging? Can you still hear me? Oh no. Can you still hear me? Or is the screen lagging on me? Can Oh, but the screen cannot move already, or why Okay, it came out already. Okay, so let me continue. I um okay, back. Okay. Yeah. Okay, so it is neutral because it's having the same amount of proton and electron. Okay, so 11 proton, 11 electron, positive 11, negative 11, so it's equals to 0. Okay, it looks like a face here. Okay, then for ion, right, it is having positive or negative charge. Where does the charge come from? It is having charges because the proton and the electron are different. Proton and electron are different. Since they are having different number of proton and electron, this is what gives it the charge. Okay, so for example, if my sodium ion now is having 11 proton, but only 10 electron, it will be a positive 11 and minus 10. So in the end, it gets a charge of positive 1, or you can also call it as 1 positive, 1 plus. Okay, understand? So atom, no charge because proton and electron is the same. Ion always carry charges because their proton and electron is different. If I have proton more than the electron, I get positive charge. If we have electron more than the proton, if we happen to have more electron than the proton, then it will be a negative charge. Is that okay? Can understand? Okay, if understand, then you write it down. Okay, later on, I'm going to tell you like why the proton and electron will be different. What makes it to be different? Okay. You can write down this important thing first. Very important. Done? Done. Okay, good. That means you must understand first before you copy. Any question? No, right? Okay, good. And now, I'm going to tell you why the proton and electron will be different. So what makes it to have a different proton or electron? Okay, actually, the only thing that changes is, let me see this thing here again. Okay, so the things that makes the proton and electron be different is when an atom, okay, you have to actually know that, okay, atom can actually turns into an ion. That means ion is actually come from an atom. Yeah. So this is why their proton and electron, they are always very similar one. Okay, how can an atom turns into an ion? When atom achieve a stable electron arrangement, okay, after it has achieved a stable electron arrangement, it can turn into an ion. Okay, so for example, like the one I mentioned just now, sodium 281. Okay, how can this atom turns into an ion? When we say how can this atom turn into an ion, it's like I'm asking you, how can this sodium atom 281 achieve stable electron arrangement? So to achieve stable electron arrangement, we can either plus more electron into the atom, or we can minus electron. Plus or minus electron, yeah? So in this case, we are having 281. The meaning of stable is we want every shell to be fully occupied with electron. I doesn't want it to look empty, like 281. Oh, there's only one electron in the last shell, which it can actually fit up to 8, right? So there is a way I can modify it so it becomes stable, fully occupied, no empty space. Okay, so since we talk about plus or minus electron, yeah, guys. You can plus or minus electron. You got to ask yourself, if I were to add electron, how many electrons do I have to add into the 281? I have to add 7 electrons, right? But if I use the minus method, I only need to minus 1 electron. So guys, you have to ask yourself, you have to decide which one is the easier method to become stable. We plus 7 or we minus 1. Obviously, we go for the minus 1 and not the plus 7. You must use the fastest way to let it achieve stable electron arrangement. That's the rule. All right. So when it donated 1 electron, it turns into 2, 8. So guys, it is very important to know that when atom goes into an ion, the only thing changed is the electron. We plus and minus electron means proton will always be the same. Proton will never change. Proton is like the DNA of the atom. It stays inside the nucleus. It can never be donated or receive more proton. No. It will always be the same. So the only thing that's different now is the electron. All right. So you can see that now the electron ratio is 2, 8. So it is only having 11 proton and 10 electron. Proton is the same, so I write down here in case you forgot already. So Na is 11 proton and 11 electron. At first, that's why no charge. But now we have 11 proton and 10 electron, which is I have 1 proton more than the electron. So Na gets a positive charge. Na plus. Okay. So that means one thing you have to be very careful here is when they ask you to identify, okay, when they ask you to identify electron arrangement of an atom, the number of proton or number of electron for an ion, you have to always refer to this here. So the electron arrangement of the sodium ion is 2, 8. 2, 8, which means it also has 10 electron. But number of proton, okay, this is the 2 ways of them setting the questions. They can give you this standard representation, Na 2311. They ask you, what is the electron arrangement of sodium ion? So when you say ion, you do write 281, please. Okay. Or sometimes they will give you the electron arrangement of Na plus, which is 2, 8. And then they ask you there are how many proton. Students very often they do mistakes like, oh, this one is 10 electron. 10 electron is same as proton. Then your answer will be wrong. Yeah. If you want to reverse back from ion to atom, very simple one. To get back the actual electron arrangement, this is what you do. If you see the charge is +1, yeah, you just add 1 electron at the back. It became 281. It works all the time. I give you more example. I give you more example. Okay, for example, I have X. When I say X, okay, I do it this way. X2 negative and X. X2 negative was 2, 8. Okay, guys, I have some question here to ask you. This one doesn't have charge, so it's an atom. This one has a charge, so it's an ion. So my question is, there are how many protons in atom X? There are how many protons in atom X? There are how many protons in atom X, guys? Oh, very good. Oh, you all can get the answer very fast. Good. There are how many protons in atom X? Okay. Okay. Thank you everyone for the answer. You just give your answer, don't worry. I'm not going to mention your name. So no one will know whether your answer is correct or wrong. You just give me the answer. Don't worry, yeah. So see guys. So according to my method just now, I said, okay, you see, to get back this electron arrangement, okay, from ion, I want to go back to atom, yeah. The original form, okay, is, okay, electron arrangement is 2, 8. It comes with a charge of 2 negative. 2 negative means what? Minus 2 electron. 2 negative is minus 2 electron. So you ask yourself, if I minus 2 electron from 2, 8, what am I going to get? I'm going to get 2, 6. So the answer is 2, 6. Okay, so the answer for proton is 8. 8 proton. Now I prove it back to show you. So if atom X was having 2, 6, it has to receive 2 electrons to become stable, right? Okay, when it receives 2 electrons to become stable, okay, it was having 8 proton, 8 electron. But once it received 2 electron, it became 8 proton, but 10 electron. I have 2 electron more than the proton, so it comes with a 2 negative charge. Understand? Can, right? Okay, so let's try again. Okay, let's try again. One more, one more. Okay, one more. Like this. Okay, I don't know what's the electron arrangement of this atom X. Okay, I know that it's X3 plus. It comes with 2, 8 as well. Okay, my question is, what is the number of electron? Okay, what's the number of electron in ion X? So there are how many electron in ion X? Okay, there are how many electron in the ion X? Okay, come try. Don't worry, I'm not going to mention your name. Okay. Okay, I see all your answer already. For those who gave me your answer, thank you very much. Thank you very much. Okay, good. Okay, see ya, guys. Okay, thank you for the answer. Okay, see. Okay, I said ion X, right? Which one is ion X? Which one is ion X? This one, the right-hand side one. So that's why I said you have to be very careful. Because in exam, they will only say ion X. They are not going to mention it like, okay, what is the number of electron in the ions X3 plus? They're very bad one. They won't tell you the charge, guys. So that you will confuse and think, oh, okay, you're asking me X, this one. No, I'm asking you ion, this one, on the right side. Since it is having an electron ratio of 2, 8, it's having an electron ratio of 2, 8, so it is 10 electron, guys. It's 10 electron. So a lot of you gave me answer 13. 13 is the electron for atom. See, 3 plus, that means I have to plus 3 to make it 283. Yeah, this one is 13 electron. Oh, wait, what happened to the screen now? Can I share the screen again? What gonna scam already? This is very obvious already. Wait, I don't know what happened. Okay. Okay, wait. I share my screen again. I don't know why. It's lagging a lot. Okay, can. So 13 electron is atom X. 30 electron is atom X. 10 electron is ion X. Is that okay? Can Okay. Last since there are still a lot of you got the wrong answer. Okay. Last last. Okay. I go with X and X negative. Wow. Is my voice lagging actually? Or just the screen? No. Okay, this one is a 288. This is a 288. So my question is, there are how many proton in ion X? There are how many proton in ion X? How many proton are there in ion X? Oh, this time a lot better. Okay, there are how many proton in ion X? Okay, 升天呐。Okay, so here, how many proton in the ion X here? Since I know that proton is always the same, I don't care whether it's proton, I mean for atom X or ion X, they are always the same. Can I straight away use the 288 and I say, oh, this one has 18 electron, so 18 proton? Cannot do that. Okay. Because in the ion, proton and electron, they are different. So what I have to do is, I always go back to the atom form. A negative charge means I have to minus 1 electron here to get 287. So 287 means it is having 17 proton, 17 electron. Since atom and ions has the same amount of proton, so the answer is 17. So to prove it right, you can see 287 has to add one more electron to become stable, 288. So once I add another electron here, it became 18 electron versus 17 proton. I have one electron more than the proton. That's why I get a negative one charge. Is that okay? Can, right? Okay, just like that. So if you can understand everything already, so I give you some time to write down the notes. Okay, here. Done? Done, ah? Then we have another one, this one. Eh? No need, this is the example. This is the example. Eh? Uh, okay, I think this one copy already, right? I forgot it. Yeah, okay. Okay, like that, oh. Okay, we have 3 examples just now. Uh, if there's any example you want to copy down, you can copy down now. Okay, or you want to screenshot also can. Any question? No question? No, ah? Okay, if no question, here's the last thing for the atomic structure. Last. So exam also very often they come up questions like the isotopes. Okay, what's isotopes? We Isotope simply means it simply means siblings. Okay, it means siblings. What's the meaning of siblings? Siblings is they come from the same family. People they come from the same family, we call them as siblings. Okay, so isotopes are actually atoms that come from the same family. Siblings, how do I know that? Okay, they are come from the same family or not? Is there any test I can do to find out whether the 2 person are siblings or not? Let's say I say Jung Hao and me are siblings. You're like, oh, I don't believe that. But we can actually do a test to know whether they are siblings or not. Okay, we do the DNA test, right? In real life, can do the DNA test to find out whether they are siblings or not. So isotopes, since they are siblings, they should also share the same DNA. And the DNA for isotopes are actually proton. So in order to know whether the atoms they are isotope or not, they are siblings or not, you just look at their proton. Because proton is locked in the nucleus, it will never change, just like the DNA. Okay, electron I can donate, I can receive, I can plus minus to change the number, but proton can never be changed. So you can just refer to the proton to know whether they are siblings or not. Same proton, siblings. Siblings, isotope. Okay. So remember, proton is always having the same and proton pula. I think I write it this way. I write this way. Okay. When you are writing when you are writing the definition for isotopes, we call them as if the siblings are, they are called people, okay, let's say people that from the same family with same DNA, let's say. This is how we understand siblings. So we come to chemistry. Isotopes are atoms of the same element with same with the same proton number, but different nucleon number. Yeah. So people is like atom, same family, we call it same element. So element is actually like family. It means family. So when you're first learning chemistry, there are a lot of these kind of terms like called isotope lah, element lah, which makes you very confused. But actually, yeah, if you can relate it to something in real life, it will be quite easy to understand. And then when you're writing this definition, please be very careful. Same proton number must always come together with different nucleon number. If you want to change it to number of proton, it must always followed by number of what? Number of what? Number of? Anyone knows what's the answer? Number of? Different number of? Yes. Different number of neutron. Okay, cannot be nucleon. Yeah? Nucleon is straight away wrong. So that means we have to see which one you prefer. You prefer writing the word number at the back, or you prefer writing the word number in front? Number of proton have number of neutron. Proton number, nucleon number. Okay. You can't write a different neutron number. Cannot. Because there's no terms like this. That means that no one design, like you are not allowed to create a new terms yourself. We only created nuclear number and you have to use it. You can't create your own one, like number of nucleon. Cannot, you're not allowed. So there's like certain rules, okay? They created this one, you must use this one. Okay, can. So like there's no really like why, okay, cannot. It's like they're just not happy. They're just not happy. Yeah, I designed this term for you already, and then you want to use, you create your own one. I'm not happy, so I give you wrong. All right, can. Okay, so this is something you want to write down. Okay, that's all. Okay, once you finish everything already, you let me know. Okay, can, done. Done. Okay. The rest of you, done. Okay, done. Let's do some questions now. So In order to know whether you learn something or not, okay, now we will go through questions. If you can answer the questions without referring to the notes, when you look at the question, you know, oh, this one we know, and then that means you learn something. If you look at the question, you'll be like, oh, I want to refer to the notes. I mean, you didn't learn anything. Okay, so like questions. Okay, I think we go to the page. Wait, let me see. Um, okay, we do two questions. Okay, we have to be fast. Okay, page number 12. Look at page number 12. Page number 12, yeah. Okay, they ask me, what is mean by proton number and what is mean by nucleon number? Okay, don't refer to the notes. I want you to write the definition for nucleon number first. Okay, write the definition for nucleon number, which is the one you copied just now. Don't refer to the notes. Don't. Okay, so atoms of the same element, remember, must write this part down. Because a lot of people, they only remember, oh, sorry, what am I doing? Shit, oh no, oh my god, oh, okay. I'm sorry, guys, okay, I thought this is isotope, I'm sorry, okay? Okay, nuclear number, sorry, nuclear number is proton plus neutron, right? So it is the total number of proton and neutron in the nucleus of an atom. I am very sorry. Total number of proton and neutron in the nucleus of an atom. Can I say some? No. Definition, when they mark questions for definition, they're very strict one. They want it to be almost like exactly the same. So total number of proton and neutron in the nucleus of an atom. So when you wrote your answer already, you can also maybe use a red pen or something, a pen with different color to highlight this part. This is the common mistake that people will make. All right. So that's proton will be the number of proton in the nucleus of an atom. So basically for proton, we just write number of proton in the nucleus of an atom. You see, the answer is the same. Okay, then, guys, state the number of electrons in the atom T. There are how many electrons in the atom T? Be careful, okay. Atom T. Okay, good. The answer is 19. Because this is an atom. Okay, they told you already. Everything here they are atom. Atom means they are having the same proton and electron. So 19 proton will give you 19 electron. Okay, then I have a question here. What is the number of electron in ion T? There will be how many electron in the ion T? See, you can get it right or not. There are how many electron in the ion T? Right, very good. Correct. The answer is 18. Nice one, guys. Anyone don't understand why is it 80? Let me know, yeah. Okay. What is the number of neutron for atom T? So to get the neutron, we use 39 to minus off the 19 to get 20. So the answer is 20. You can just write 20. I write down the workings here is in case there's anyone who don't know how to get the answer. Okay, so if you don't know how to get the answer, you can write the working down. Okay, define isotope. Sorry, this is the one you have to write. Okay, define isotope, please. Okay, write it on your own. I give you 30 seconds. Okay, that's all. Atoms of the same element with the same proton number but different nucleon number. So which pair of atoms are isotope? Explain your answer. So R, S, T, and U. Which one of them are isotope? So since we say isotope are having the same amount of proton, so we can see S and U, they're having the same amount of proton. So our answer will be atom S and U. They want me to explain. When they want you to explain why is that an isotope, you just throw the definition in, which you will say, because the atom U and S, the atom S and U, they have the same proton number, but different nucleon number. So we use definition to explain this. Yeah. Same proton number but different nucleon number. Or you can say have the same number of proton but different number of neutron. Okay, next. State two different physical property between the two isotopes. Different physical property. Okay. Every time when you see physical property, you can always mention this. Melting and boiling points. Melting and boiling points in other chapter also. Every time when they talk about physical property, they will mention melting and boiling point. So this is a very what I would say a useful answer. Okay, for this chapter, for other chapter as well. Okay, in the form 4, form 5. Okay, then next. Another physical property is density. You can write density. You can write relative atomic mass. So physical property is usually something measurable. Something measurable. Like, okay, we can measure the melting and boiling point. We can measure the density. We can measure the relative atomic mass. Okay, how do I know that their mass are different? Nucleon number is also the relative atomic mass. Because in an atom, the mass is all come from in your syllabus, the mass of an atom is totally come from proton and neutron. Because the electron, the mass of an electron is very light. The mass of one electron, yeah, guys, is 1/1840, which means you will need 1,840 electrons to have the same mass as one proton or one neutron. That's the meaning. When your teacher go through this one, equals to one proton, one proton or neutron. So this is why when the teacher go through this one, she told you that, okay, so the relative atomic mass for proton is 1, relative atomic mass of neutron is 1. So 1/1840 is, you need 1,840 electrons to have the same mass as one proton or neutron. The mass is very light, so we will actually ignore the mass of electron. Okay, so nucleon is the relative atomic mass in your syllabus. All right, okay, next. Atomic size. Try not to write atomic size. Okay, try not to write atomic size because they are having the same amount of proton. So most likely their electron emission is the same, so the size will be most likely the same. So don't write that one. Because the difference is very slight, a very, very slight difference. Almost not able to measure. Reactivity can or not? Cannot. Okay, look at the next question. Will the two isotopes react the same way? Okay, since you talk about reactivity, I get it. When the question asks me, does these two things react the same way? This question also is actually the same when they ask you, are they having the same chemical properties? Are they having the same chemical properties? It's the same as, do they react the same way? Okay. So how do we know whether they react the same way or not? React the same way or chemical properties, that actually means the way to become or achieve stable electron arrangement. So do they use the same way to become stable? Do they use this? Do they have this? Sorry, I'm repeating the same thing. React the same way, they use the same way to become stable. The answer is yes. So what kind of thing will react the same way, and what kind of things they use the same way to become stable? It is related to their valence electron. So for this kind of questions, we will always say it's because the atom S and U have the same number of valence electron. That is yes. Because they have the same number of valence electron. Okay, you write down the answer first, then I explain. Okay, so why do we have to mention valence electron when we talk about reactivity? They react, the way of how they react, and chemical properties. So imagine we are having 27 and 287. These two also has the same chemical properties. That means they use the same way to become stable. So how can an atom become stable? It totally depends on the valence electron. How do they interact with the other atoms? It depends on the valence electron. All right, can yeah. So just like that. So chemical property is talking about whether they donate or receive electron. Okay, then next. Example of isotopes in different field, okay, and their uses. This four example is something that you must study before exam. So in the medical field, usually, I should ask you all, okay, but never mind. Cobalt 60. Cobalt 60 is used to treat cancer. Yeah, correct. Or they are being used to sterilize surgical instrument or surgical equipment also can. So it's like the surgical knife, the scissors or what, they have to put into a machine that has this gamma ray radiation to kill all the virus, the bacteria, or the microorganism. So in case they come out in objective, okay, this is also, this can be also the answer, yeah. So in the agriculture we uses phosphorus 32. Zoe, very good. Phosphorus 32. Phosphorus 32 is actually a fertilizer. It is a fertilizer to study used to study the metabolism in plants. So that means I will feed the plants with this fertilizer and then see how fast they can absorb this fertilizer. If they can absorb very fast, that means they're very healthy. Okay? If they absorb very slow, then their metabolism rate is low, not very healthy. Okay. In the archaeology, we use the carbon how much, guys? 40? Carbon 14. Okay, carbon 14. Carbon 14 is used to estimate the age of fossil. Yeah. Estimate the age of fossil or artifacts. Cannot say determine, must be estimate. Estimate only. They cannot accurate calculate. It is 1,000 years ago. How many months, how many days, cannot. They just predict around, okay, how much. And then for industry, they always like to test you on the sodium 24. Yes, sodium 24 is to detect leakage in the underground pipes. Must mention underground, yeah, guys. Leakage in the underground pipes. Okay. It's like that. Okay, then continue. After these three questions, I give you a short break. So suggest the physical states of substance PQR at room temperature. So last week in the class, we just did question like this. What is it? Suggest the physical states of a substance at any temperature. This is what we do. Okay, guys. How much is room temperature? You still remember how much is room temperature? Yeah, room temperature is 25 degrees Celsius. Room temperature is 25 degrees Celsius. Okay. So in order to know the physical stage, which is solid, liquid, or gas, all we have to do is we try to put this temperature into the range of the melting and boiling point. So that means we have to compare and see this 25 is smaller than negative 183, bigger than negative 183, or bigger than negative 89. If, okay, the temperature is more than the melting point, means it can turn from a solid to liquid. When it reaches the boiling point, it turns from liquid to gas. So all I have to do is I try to put it in range. 25 is obviously bigger than negative 183, and it is also bigger than negative 89. So P will be in a gas state. And I do the same thing for the other two. 25 is in the middle. It's between 15 and 70. Yes, so it is a liquid. And the last one, 25 is smaller than 900. So it is a solid. So P is gas state, Q is a liquid, while R is solid. Okay, since we talk about this, guys, let me mention this as well. Please don't make careless mistakes like this. When the question is asking for physical states, questions are asking for type of particles. Questions are asking for subatomic particles. Okay, students very often give the wrong answer. Physical states has three answers: solid, liquid, gas. Type of particles are which three? What are the three types of particle we have? What are the three types of particles we have? Yes, correct. Very good. Atom, molecule, and ion. While the subatomic particles are proton, electron, and neutron. Yes. So because they are all like three answer, so students very often will give the wrong answer. Very important. In exam, normally they should come out on. They should come out on either one of the question here. Okay, so make sure if you want to temper in the correct area. If they ask for type of particles, temper among these three. You don't temper others now, of course. Okay, understand, just like that, very important one, in exam should come out on. It's like in almost every exam. Sometimes they come out this, sometimes this one, sometimes this one. So you have to remember this until SPM. Okay, can? Okay. Continue, Okay. We are running out of time. Okay. So boron exists naturally as two isotopes, which are 19.9% of B10 and 80.1% of B11. Calculate the relative atomic mass. This type of question is very easy to identify. When you see they want you to calculate the relative atomic mass, and then the questions come together with the word isotope. If they want you to use isotope to calculate relative atomic mass, the method must be like this. Okay, they told you that boron 10 is 19.9%. Boron 11 is 80.1%. Relative atomic mass means the average mass. They want you to find the average mass. To find average mass, okay, you see, this number is the nuclear. Nuclear is the mass. All you have to do is you use the number to times the percentage and then you use the total to divide 100. So this information is kind of telling you that, okay, I have 100 atoms now. Okay, let's say I got, let's say 20 atoms. Okay, they are having a mass of 10. And then I'm also having 80 atoms that has a relative atomic mass of 11. So what is the average mass? In my class, got 11 students. I mean, 11 plus 100 students. 20 students has a mass of 10 kg and 80 students has a mass of 11 kg. So what's the average mass? That's how you do. Total divide 100. Okay. Press your calculator and then you are going to get, wait, how much you got? You got 10.8, yeah? Okay, 10.8.喂，阿阳，你在这边呢？你几时在这里，阿阳？Okay 10.8 just like that. Thank you very much. Okay, next. Sulfur has two main isotopes. 那就代表着你现在才回答我的问题了。Okay, so two isotopes. Sulfur 32, sulfur 34. Data from the experiment shows that the relative atomic mass is 32.1. So you see, atomic mass 32.1. They give you isotope. You can see this. It's the same thing again, but this time they gave you the final answer and you have to find the abundance of both isotopes. The abundance means the percentage. So they want you to find out how many percent of sulfur 32 and how many percent of sulfur 34 they have. Okay, so in this case, this is how you do that, okay, basically. So sulfur 32, I do know there's how many percent. Let's put it as X percent. Okay, put it as X. I have S34, and the percentage of the S34 must be 100 minus X. Do you agree? Agree, right? Okay. So all you have to do now is 32. Okay, we say about times the percentage. So you 32 times X plus 34 times 100 minus X divide 100 to get 32.1. So if we press our calculator, it will be something like this. I write the full workings just in case anyone of you cannot get the answer. It's 32x plus 3,400 and minus 34x equal divide 100 equals to 32.1. So I move the 100 to the opposite side first, guys. Top. After I times 100, it gets 3210. Understand? And you can move everything to their side. Okay. Let's say I move the unknown to the other side. So it will be 3400 minus 3210 equals to 34x minus 32x. So I get 190 equals to 2x. So x is equals to 95. Okay. Why 100 minus x? Because you see, percentage must be 100% one, right? Total. Like this one. Okay, if I show you the value here is 19.9 already, how to find the percentage of the other one? 100 minus 19.9, you get 80.1, right? So that's why we do 100 minus x. 100%. So x is equal to 35. So that means sulfur 32 is 95%, while sulfur 34 is 5%. Like that. That's the answer. Why sulfur 32 must be X? You can, it can be terbalik, guys. It can be terbalik. You want to put sulfur 34 as X also can. Can. You get the same thing, can. It doesn't matter one. Okay? And now it will be the same answer. Okay, can. It doesn't matter which way I put an X as long as there's one X and the other is 100 minus X, they'll get the answer. Okay? Yeah, just like that. So this is the answer of after I use 100 minus 5. 100 minus 95 to get 5. Okay, any question? Okay, no. Okay, I give you all a 3 minutes break. Okay, toilet break or whatever, lunch break, breakfast break. Okay, so come back later. Okay, I just set a timer here. I set a timer here. 3 minutes. Go. Bye bye. Drink water or what? Get water something. Okay, back. Ah, okay, 来啊 continue 啊 So let us continue. If you're back already, can you please send me an emoji? Hello, hello. If you're back, can you send me an emoji? Hello, 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 hello. Send me an emoji. Hello. Hi everyone. Hello. Yes. Hi, 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 hi. Okay, let's continue. Okay, now we got to do the chapter 3 of all. Okay, calculation and also the empirical formula experiment. Calculation, I'm not going to do much, okay, because you can just practice yourself. Okay, so here's the way of how you can do the calculation. If you find it very hard to do, like the chemistry calculation, I cannot understand the question, it's very hard. This is what you can do. First, you ask yourself, if you cannot do the questions, do you actually know what are the formula you have learned? So to do calculation, the first thing is the calculation formula that you have learned. We have three calculation formula, which is number one, mole equals to mass over molar mass. Number two, we have mole equals to volume over molar volume. And finally, number three, we have mole equals to number of particles over the Avogadro's constant. The Avogadro's constant is usually 6.02 times 10 to the power of 23. Okay, so there are these three formula. So first, you have to remember the three formula. Then you have to know their unit. The unit for mass is gram. The unit for volume must be dm cube. So if they happen to give you cm cube, and you want to convert it into dm cube, you have to divide 1000. Because cm cube is actually ml, while dm cube is liter, they are the same. So ml to liter, you divide 1000. dm cube to cm cube times 1000. Okay, and then for number of particle, it can be usually atom, molecule, or ion. And there's actually another one. It's called formula unit or unit formula. Okay, that one if you got time, we mention that one later. Okay. So first thing first, remember the three formula. And then the steps in doing your chemistry calculation is identify which formula to be used first. If you are able to identify which formula to be used, all you have to do next is sub in the correct value into the formula. That's how you get the answer. It's very simple. Students make mistakes. Okay, very often make mistake is because first they are not sure with the formula. They don't know which formula to use. And then the second thing is they simply sub value. They simply sub. Yeah, it's not that hard. Okay. So this thing you can write down if you want. Okay, you can write down if you want. But I think it's in the notes, okay? Not uh, no need to write down also can. But the steps here. So which formula do we use? And then sub in the correct value. So let me show you how to use it. Okay, we straight away go to the page. Okay, I think we can start with page 26. Okay, here it says, I do you want this one first? We do Okay, this one, 27, sorry. 27. Okay, 27 first, huh? So here, easier one, this one. So it's made of carbon, hydrogen, and oxygen atom. So it shows a molecular formula of vitamin A. So when they give you a structure like this, all you have to do is count one by one. So first, you count the carbon. Okay, there are how many carbon? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20. C20. You help me to count also, just in case I count wrongly. Okay, C20. And then H. How will you calculate the H, please? Count there how many H. How many? Yeah, how many H? Huh? How come I got 27 only? Oh, correct. Oh, 30. Oh, thank you. Thank you very much. You see, luckily you all count for me. Okay. Then O got 1. C20, H30, and 1 O. Let me know if I count any of the formula wrongly. Okay. So students always ask me like how do you know which one to be placed in front? Like you put the H first, or I put the C first, or anything is okay. Uh Normally we follow the sequence of your alphabet A to Z. So it start from A and to Z, right? So C first, H, and then O. This is the easiest method. So C20, H30O. Determine the mass of 1 mole of vitamin A. So you see, when they say determine the mass of 1 mole of vitamin A, you see mass, you see mole, right? Okay. So which formula to be used? They mentioned about mass and mole. Of course, I use the first one. If you're not good with calculation, this is what you can do. So I have decided to use this formula, mass over molar mass. Then I write out the formula first. Write the formula out. Okay. Then sub in the correct value. Okay, what do I mean by sub in the correct value? First, you have to know what the question is asking for. They want you to find mass. They want you to find mass. Then you have to make sure that this mass is locked. You can't sub in any value for mass. Don't sub in anything for the mass. I have to sub mole, I have to sub molar mass. This is how I can sub correctly. Okay. Yeah. So I sub mole and I sub molar mass. So how many moles? They say 1 mole. So I sub 1. Mass cannot touch. Okay, put there as M. Molar mass. Yes, molar mass is RAM. Correct. This relative atomic mass is the RAM. Relative atomic mass, or we so call it as molar mass. C20H30O. Then you saw C20H30 plus O to get 286. Wait, how come you also got so many different answers? Okay. Two hundred 86. Correct. Okay. Can Can ah? Yeah, that's what I got. Okay, no, guys. Can 286 The molar mass is okay. Okay. I think there's another common mistake that students will make during their calculation. So if you know that uh you always make mistake when you are pressing your calculator, okay, then you try not to press the whole thing at one time. You always separate it. You do parts by part. This is what I do. When I do my calculation, I always press this one first. I get the answer already. Then I only press answer times 1. Answer times 1 to get the final answer. Okay? Can like that. Mass is gram. That's all, just like that. Determine the mass of 0.025 mole of vitamin A. So same thing, they want mass. They gave me mole. So I use mole equals to mass over molar mass. They want me to find mass. So I sub mole and the 286. Yeah, you can, okay. You won't be getting any marks by writing the formula. Okay, by writing the formula, you don't get any marks. Okay, but this is a very good practice for those who are still very weak in doing this calculation. If you are good, you can skip this for sure. But you know that you are not that good and you are trying to improve, this is a very good way that you can practice. For sure, your calculation will become very good one. Okay, so decide the formula, then only you sub. Marks will be given for this and this. So this kind of question can usually go up to 2 marks. Calculation working here are 1 marks. Final answer 1 mark. And then remember, if they only give you 1 mark now, if they only give you 1 mark, you don't think that, wow, usually they give me working 1 mark, answer 1 mark. Now they only give 1 mark, I give them the final answer only. Don't like that. Don't like that. Do for them, okay? You just write everything with the answer. They want to give you 1 mark or 2 mark, they will decide. Okay? Must have working and answer. And then only write unit for the last final answer. Try not to put any unit here, guys. If you are not very good with unit, don't put unit here. You only put unit for final answer. Okay. So this one I get 7.15 gram. 7.15 gram. Okay, continue. Okay, continue. They say, determine the number of molecule. Present 20.02 gram of vitamin A. When I see number of molecule, I know that I'm going to use which one? 1, 2, or 3? Number of molecule. Yes. This mass, this volume, and this atom molecule ion, right? So I use the third one. Yeah. So I have to use mole equals to NP over 6.02 times 10 to the power of 23. Or very often, school teacher will just write NA. The Avogadro's constant. Same thing. Okay, they want me to find the number of molecule, which is here. Okay, they want me to find the number. NP is number of particles, so number of molecule. That means I have to sub in mole. You see? 6.02 times 10 to the power of 23 already given NA. So it's here already. So I have to sub in mole. But do I have mole? Do I have mole? No. Okay, then never mind. I continue to read my question. It says 20.02 gram. They gave me mass. Mass should be this formula. Okay? Just now is the third one, now is the first one, means I have to use two formula. So I write mole equals to mass over molar mass. Okay, you cannot get the answer for calculation questions because you always want to try to sub everything into one formula. Please don't do that. Molecule for molecule, mass for mass. Okay, I need the mole, right? So mole is what I'm supposed to find here. Gram, we sub it on top. And the molar mass we already got just now. 286, right? So we get 0.07 mole. Yeah, then I can sub the mole here. To get the answer, 4.214 times 10 to the power of 22. And then unit, right? Okay, unit. Particle can be atom, molecule, or ion. In this case, okay, I know most of the students, they will write, molecules. When they ask them why, what makes you think that it's molecule? They will say, the question already mentioned, the question already mentioned molecule, you just write molecule. That's not the correct way, guys. That's not the correct way. Because I can always change it to atoms. You can't just say, because they want me to find atom, then I put atom. That's not how you get the unit. Okay, sometimes they give you the fake unit. You have to ask yourself, okay, to decide this unit, you have to ask yourself, this is the amount of what? Vitamin A. What's vitamin A? This is vitamin A. C20H30O. So I have this amount now. I have this amount of C20H30O. C20H30O, is this an atom or molecule? It's molecule. Then I write molecules. That means we decide the unit based on the formula itself, the chemical substance. If it's molecule, then only we write molecule. After you write molecule, you check with the question and see, same or not, is that what they want? Oh yes, that's what they want. Then that's the answer. You might want to say, there's no difference, you're doing like this. Okay, see, if the question is asking for atom, now, let's say, okay, we put an arrow here. Determine the number of atoms. Okay, this is how I do. After I got the 4.214 times 10 to the power of 22, I'm not gonna write atom straight away. I will still ask myself, okay, what's the substance? Oh, C20H30O. This is a molecule, so I still write back the molecules. But the question's one atom. What do I do? Convert unit. So in mathematics or like physics or what, very often they will ask you to find something in different unit. Like they will say find the mass in kg, but the question gives you gram. Then you have to convert the unit. When we convert molecule to atom, it's always times. It's always times. From bigger, this thing is big at first. You want to separate them to become smaller atom. It's times. If you don't understand why, you can write this example down, which is, I very often ask my student, okay, you cannot understand why molecule to atom is times, right? You ask yourself, if you have one H2O molecule, Okay, you have one water. This is a molecule. Okay, one H2O molecule has how many atoms? How many atoms means it can be separated into, yeah, 3 atoms, right? Yes. Then if you have 100 H2O, how many atoms? Student will tell me that, 300 lor. One H2O is 3 ma. 100, then 300 lor. How you got the answer? How you got the answer? Times 3. Then if I change the value to like 125, how many atoms? You do the same thing, you times 3. So don't be afraid of a number like, okay, when you see a number like 1.208 times 10 to the power of 23, don't be afraid. It's just a very normal number. You just look at it as a very normal number. Molecule to atoms is always times. You just times. You get the atoms. Understand what I'm trying to say? Okay. So in this case, molecule to atom is times. Times how many? There are a total of 51 atoms here. 20C, 30H, and 1O. A total of 51 atoms. Then we times 51. To get 2.149 times 10 to the power of 24. Okay, can I? Yeah. If they want a specific type of atom, they only want hydrogen atom, then you times 30. If they want carbon, you times 20. Total, then plus everything up together. Okay, just like that. Okay, continue. Okay, continue with this question. Can you all try to do this yourself? They want you to find mass, but they gave you a number like this. So decide which formula to be used first. And then sub in the value correctly. Oh, very fast. Okay, so they gave me mass. I have to use mole equals to mass over molar mass. I'm looking for mass. I have to sub mole, I have to sub molar mass. They gave me this long number, which means I have to use mole equals to NP over 6.02 times 10 to the power of 23. So let's say I start doing with this here. I do know what's my mole. I do know what's the, okay, mass is what I'm looking for. Molar mass, I got 286. Okay, that means I still need a mole now. So this one I have to find mole. And also very obvious that this value can only be sub here. when you are pressing your calculator, remember to put a bracket at the bottom so that you can get 0.125 mole. Sub the 0.125 mole into your formula, and you are going to get 35.75 grams. All right, Hannah. Okay, no question. Then we go next. Okay, next page. Okay, try to do two more questions. So page 28. So again, there's a formula here. Okay, start counting the all the atoms. Wait okay, you count yours and I count mine. Is my formula correct? C8 H11 and O3. Yeah, okay, thanks. Name the elements that make up a vitamin B6 molecule. How to know which one to write first? Just now we already said how to know which one to write first? We follow the sequence of A to Z. So C, H, N, and O. Okay, Hannah. Name the element name the element that made up vitamin B6. So what are the elements used to make this molecule? Anyone knows the answer? Just give me one element. What's the element? Okay, nice. It's made of, yeah, correct. Carbon, hydrogen, nitrogen, and oxygen. Yeah, so these are the elements. We have carbon atoms, hydrogen, nitrogen, oxygen atom. No lah, it doesn't matter where you put first. This one. You want to put oxygen first, only nitrogen also can. You want to put nitrogen first, then only carbon also can. It doesn't matter. But when you're writing the formula, you follow the sequence of A to Z lah. But because you're still new to chemistry, so sometimes if you put the sequence wrongly, your teacher actually okay one. They don't care too much about that because you just started to learn chemistry, so they didn't care that much. Calculate the molar mass of B6 molecule. I need you all to give me the answer with the correct unit. Answer with the correct unit. Yeah, chemistry always they mark very strict one. They always mark very strict one. But some, okay lah, your teacher didn't give you a chance, then very hard. Okay, so what you got? Wait, why I got so many different answer one? What you got? What you got for this question? C. Ah, I got like more than three different answer now. The rest of you, what you got? Yes, I answer any. Yes, I got 169. Do you know how to do? The molar mass, remember or not? Just how we say. Molar mass is like the relative atomic mass. What's the relative mass of the... Uy? Oh, I know why already. Okay. Okay. This one, okay, sorry, I forgot to give you the relative atomic mass, guys. No wonder. Okay. Relative atomic mass for carbon, sorry, is 12. Hydrogen is 1. Nitrogen is 14. Oxygen is 16. Don't worry. They're supposed to give you this one in exam. I forgot. Sorry. No wonder. Okay. Okay, that is 169. What's the unit, guys? What's the unit? Huh? If you can't get the correct unit, your answer is also wrong. Ha ha ha. Okay. The answer is yeah. What's the unit? What's the unit for molar mass? It is 169 gram per mole. Molar mass. Okay, what's the meaning of molar mass? Molar means 1 mole. The mass for 1 mole of substance. So 169 gram per mole. Okay, remember? Okay, we write down here. If they ask what is the relative molecular mass, our answer will be 169. What's the unit? What's the unit for relative molecular mass? So you can correct. For relative mass is no unit one. When the question is asking for relative mass, don't write any unit. If they ask molar mass, it's gram per mole. Okay, then next. I want to change this question to number of atoms. Okay, right? Calculate the number of atoms is 5.75 gram of vitamin B6. I think this is the last question we can do already, right? Let's go. Number of atoms. I wait for your final answer, yeah, guys. If there are a lot of decimal, you just have to get 3 decimal places. 3 decimal places. Okay. Okay, the rest of you? Okay. Okay, good. So mole, okay, they want me to find atoms, so I'll be using mole equals to NP over 6.02 times 10 to the power of 23. We are looking for atoms, so that means NP. So they gave me mass as well, so I will be using mass over molar mass. Sub in the value, 5.75 on top, divide by the molar mass 169 to get wait, 0.034 mole. Then we sub the mole in to find the number of particles. I get 2.0468 times 10 to the power of 22. This is molecules. Okay, because the substance vitamin B6 C8H11NO3 is a molecule. So I have to write molecule first. But the question is asking for atom. Molecule to atoms, I times. There are how many atoms in C8H11NO3? 23. So I times 23 to get 4.707, that's right, 8 times 10 to the power of 23. As long as you can get 4.7 lah, okay? Your value starts with 4.7 can already. Because different people, they take different decimal place. And maybe some of you, you just press the calculator straight away just now. You use answer times the 6.02. That's why your answer will be slightly different. If you can get 4.7 can already, not 22. 24, 8 carbon, 11 hydrogen, 1 nitrogen, 3 oxygen. Isn't it 23? Right? Okay, then the mass, this one okay lah, simple lah. Find the mass, so mole equals to mass over molar mass. 0.005 mole equals to mass over 169. We get 0.845. Right. Okay, then write the empirical formula. Empirical formula means the simplest form. What we I think sorry, this one is a different question already. Sorry. It shouldn't be here, okay? Aspartame is like in another question one. Sorry, this one is about vitamin B6. It's a different thing. So that's all lah. I think the empirical formula experiment, yeah, guys. I will make a video. I will make a video, a short video, and I post it on YouTube. Then you all watch on YouTube lah. YouTube my YouTube is what you want, if you want to watch this replay video, I will also post it on my YouTube. Why chemistry? I just go YouTube search this one lah. Okay, can see you guys next time. Bye bye. Thank you very much. Okay, bye. You did read my message in WhatsApp. Which one? Come, I reply you now. What's the message?